All right. Let's go ahead and begin. A couple of scheduling reminders coming up. So the unit tests for homework 3 were due a couple hours ago. I started going through them. Didn't quite get enough time to get through them before class, so I'm hoping to get those out this evening. I'm going to do my best to get them out today. If not today, definitely by tomorrow, so that you guys can have those and use them as you're working on the homework assignment. Other things to keep on your radar, fall break, of course, is Monday and Tuesday, so no class on Monday. I'll probably be around on Monday and Tuesday, but I'm not exactly sure when. If you'd like to chat with me about the course, shoot me an email. We can make an appointment. I can meet with you on Monday or Tuesday next week. Then on Wednesday, after fall break, when you come back next week, 1 week from today, we're going to do an exam review session because the following Monday is our first exam. And so with that in mind, actually, today's content is the last new stuff that's going to be introduced before the exam. So the exam will cover everything that we've talked about up to and including today. Today is the last piece. And I got to be honest with you guys, what we're talking about today is much lower priority for me than basically everything else that we've talked about so far. So I do tend to ask a few questions about this stuff, but I will definitely focus a lot more on the B+ trees and the relational operations because that's what I've asked you to do on the homework assignments. Yeah. Yeah, I'll post some stuff. I'll try and post it before the review session next week so you can take a look at it over fall break because I know you're really just anxious to do practice exams over fall break. But yeah, 1 week from today, in class, 1 week from today. We'll be reviewing for the exam. So I'll try and get some practice stuff posted before then so you can take a look at it before showing up on Wednesday. I'm just going to have all Wednesday. I'll basically spend the first maybe 10-15 minutes going over some basic logistics stuff. And then after that, I'm just going to open up the floor to questions for whatever you want. So please bring questions next Wednesday. As far as today goes, I want to start today with a warning. This lecture has scared some people in the past. I'm going to show you some code today in PHP, and I'm also going to show you some Java code as well. I'm not going to ask you PHP questions on the exam. I've had people worried about this in the past because I talk about PHP today. They're worried I'm going to grill you about PHP stuff on the exam. That's not going to happen, guys. I'm not going to do that to you. I'm just using PHP as an example to talk about front ends. That's all. And I'm not even going to be doing anything terribly complicated with PHP today. It's just one choice that I wanted to use to show you how to construct a front end for your database. So that's what we're going to spend some time talking about today. Just wanted to make that absolutely clear. The more important things to take away from this topic are, how the general steps to setting up a front end. The language that you use is not nearly as relevant to me. And we're going to see some Java examples as well. So let's go ahead and hop into it. Frontend access is all about your users. So we all use databases all the time, every day, whether we're consciously aware of that fact or not. Do we want to use a database? In some sense, it doesn't matter if they want to use a database or not. If I'm logging into Facebook, I got to use a database. That's it. That's the end of the story, right? Facebook has databases that keep track of all that data. So whether I know about that database or not, I am using it. The next question I think is a lot more clear. Do my users want to write SQL queries? Think about if you wanted to go log in to Reddit or whatever, and you had to type a SQL query to look up your username and password. Like, the people in this room maybe wouldn't be terribly upset about that, but the average person probably would have no idea where to begin doing that. So we want to use databases for our applications, for our websites, but we want to keep them out of sight, out of mind. We want to present something to the user that is simpler than using SQL queries to access data in a database. And that's what a front end is for. A front end is basically the shiny surface on top of our database. The users can simply type in their username and password, and on the back end, we'll formulate the query, and we'll submit that to the database and interact with the database. And do all that stuff under the covers, behind the scenes, so that our users don't have to worry about that. So the two main things I want to answer today are, how do I access a database from a website and from an application? These are two of the most common database questions that I get. Not about writing SQL queries, not about how to build a database, design a database. The most common questions that I get from students about databases are, I want to make a website that uses a database. How do I do that? And so I'm going to spend a little bit of time today talking to you about some possible ways that you can do that. And then later on, we're going to introduce our first little brush with security and talk about, okay, now how do we keep our databases, our websites secure? And we'll do a little exercise to work on some of that stuff. So if I want to make a front end for a database, the basic setup is the same. It doesn't matter if I'm doing a website. It doesn't matter if I'm doing a Java application, right? The language doesn't even really matter. The basic process for setting up a front end to my database is going to be the same. Step number one is install the drivers that I need. This is the one step that might be optional depending on the language that you choose, depending on how you're interacting with this database. Might be optional. But you need to have some way for the language to communicate with the database, and that's called a driver. A lot of times these drivers are available for free online. So if I'm writing a Java application and I'm using a MySQL database, I'm going to Google MySQL drivers for Java. And the first result's going to be probably a page from Oracle that lets me download the MySQL drivers for Java. Okay, so that's step number one. Once I have the drivers set up on my computer, then the next thing to do is to create a connection to the DB. So this is now in the realm of code. Whatever language I've decided to use, I'm going to write code to create a connection to the DB, and this is going to contain the stuff that you would normally think of when connecting to a database. I need a login, a username, and a password. I need to tell it where the database is. What's the address, right? All the stuff that you need to connect to a database. We'll then prepare our query, we'll execute that query, and process the results. So what I'd like to do with you now is take a look at this in a couple of different ways. We're going to take a look at PHP first, and then we'll take a look at Java. We'll take a look at how to do it a few different ways in Java. So if you don't know PHP, that's okay. How many of you do know PHP in here? Anybody? Oh, several. Nice. Fantastic. If you don't know PHP, that's okay. That's not going to be a major hurdle for you, I don't think. I will explain as I go once I find out where I put these files. Here we go. So the first thing I want to do is take a look at a PHP script that's just going to dump a table. It's just going to dump, or maybe a subset of a table. It's just going to run a very simple query, grab some information out of a database, and show it to us. That's all it's going to do. Actually, maybe I'll show you how it works first, and then we'll take a look at what the code is. Here is actually a website, a PHP script that runs a query across an employee's table. It's the same employees table if you did Studio One, right? If you did the studios, you installed MAMP on your machine. This is the data that is in one of those tables. So this is, I believe, the employee's last name followed by their employee ID number. I don't know why it won't zoom in, but whatever. And so there's a simple PHP query running in the background to grab that data and display it on the screen. So let's take a look at, oh, there it goes. I don't know why it's on a delayed reaction today. Let's take a look at the PHP code that's necessary to handle this. It's not very long. It's not a complicated query. I've got some basic boilerplate HTML up here at the top. And now this is already like super duper red flags, not kosher at all thing to do. Don't do that, please. I am doing this to show you that you do need the username and password as part of the connection. That is a necessary piece. And you'll notice that I'm going to use these later on. This is the default username and password to the database that is installed on my computer. This is what we would call the connection string. So it's showing me the address, which is localhost. That's my computer. Localhost is my computer. So the database is on my computer. The name of the database that I'm accessing is called employees, and the port number that is used to access that database is called 8889. Where do you get this information from? Well, once you set up your database, once you install your database, design and implement your database, that's when you actually make the decisions as to what the host is going to be, and what the database name is going to be, what port is going to be used. So these are the values that I set upon installation of the database on my personal machine. So I've got the connection string that tells me where the database is and what database I want to access. I've got my username and password, and I'm going to create a data object. This is the DO in PDO stands for a data object. I'm passing the connection string, that's the first variable. I'm passing the username and the password to use to log in to this particular database. That's step one, connect to the database. Step two is to formulate a query. So you can see in this simple example, I'm going to use my data object to construct a query for me. What query do I want to run? Very simple in this case. Select first name and employee number from the employees table. Very simple query. We'll take a look at more complex stuff a little bit later on. The results from this query will get, the prepared query statement will be stored in this variable, and then to actually execute the query, I'm going to call the fetch method on it. This while loop then will go through all of the results, and for every row, it's going to echo, this is a map or a dictionary, however you want to think about it. First name will get me the first name column from the row. Employee number will get me the employee number column from the row, and print it out on the screen, which is exactly what we see when I visit this page. This is an execution of this script. I actually have a database on my computer that's running. This data comes from that database. So this is about as simple as it gets. This is about as simple as it gets. Now in practice, we want to do things that are a little bit more complicated than this, right? In practice, I don't just want to do an information dump. I want to do an information dump based on what my users want to see, how my users want to interact with the website. So a classic case is, logging in. I'm going to provide you my username and password, and then once I've given you the correct password, I'm going to only show information that's relevant to that user. So I need to have some way of performing a query that's based on who's logged in. Or I need to have some way of performing a query based on information that a user is going to type into my website or my application, into a text box. That's a more common way of interacting with the database and a more useful way of interacting with the database. So let's take a look at a more complicated example to do this, something like this. Instead of printing out all of the employees, I want to take a look at a way to simply select an employee that we care about from the database. So I want to ask the user now to type in an employee's name. I'll look up that employee and only return that person's information. It's a lot more useful than just dumping everybody's information onto the screen. So I have a second PHP script that will do exactly that. There's a form. This is not actually really a whole lot of PHP. This is a straight HTML forms. Again, if you're not familiar with HTML, don't worry about it. I'm not going to ask you to write HTML in the exam or anything like that. For those of you who are aware of HTML, quick tour of this. I've got a first name and a last name text box, and the results are getting sent to this process form PHP script. So if we take a look at that, that's where the exciting stuff's going to happen. Again, I've got my username, my password, and my connection string, just like before. I'm creating a data object, and now instead of specifying the query, you can see that I've got question marks in here where first name equals question mark and last name equals question mark. Those are placeholders for the data that has been typed in to that form. Those are placeholders. And so when I execute the query this time around, I have to supply it with an array of values to go into these placeholders. There are 2 question marks in my query, so I need to provide an array with 2 values where these are the values that were typed in to the form. Those are the values that were typed into the form. It'll execute the query, iterate through all the rows, print out the name and employee number for all matching employees. So let's take this one for a spin. We want to go to name form for this one. And it's asking me for the first and last name. I know there's a guy in here named Parto Bamford, which is a great name. Love Parto. We go way back. And if I hit submit here, it looks up Parto and his employee ID number is 10,003. Right? This is a much more useful application. I can now target specific data. This is what's called a parameterized query, right? This example here is called a parameterized query because we've got placeholders in the query, and then I'm substituting values into that query based on what the user typed into the box. All right. Are there any questions about either of the PHP examples? So I just wanted to show you a web example. PHP is sometimes popular and sometimes not. I have no idea if it's popular right now or not. It seems like it changes every year. Not popular anymore? Okay, yeah. Whatever. I mean, it is what it is. But the idea is the same, whether you want to use Python, JavaScript, right? Whatever web coding language of choice, the idea is going to be the same. Connect to the database, formulate your query, pass in user information if necessary, and then execute it and process the results. The process is going to be the same. Any questions before we take a look at a different version? So what I want to do next actually is move away from the web stuff and talk about language that I suspect more of you are familiar with, which is Java. I want to take a look actually at very similar examples to the ones that we just looked at in Java. Let me see if I can zoom in on the text here real quick though. Whoops, wrong thing. Where are my preferences? It's been a while since I've had to change the text size here. Can you just zoom in for me? Is that a thing? Oh, there we go. I figured it out. So here's a similar example to the first example, the first PHP example that we saw. The first thing that I'm doing in this example is a little bit different. I am loading the driver. Where the driver is actually over here. I know the text is really small to see, but this jar file that I have highlighted is the MySQL driver for Java. I went online and I downloaded it. I added it to the project. So step 1 is acquire the driver. Here it is. I've acquired the driver and put it in my project. This is the tool that I need to connect to a MySQL database in Java. And so you can see in my code now, I am looking for this driver and then setting up the connection where, just like we saw in the PHP code, I'm doing it with a connection string. And I'm passing basically the same information, right? Here's the location, here's the port number, here's the database that I want to access, and then the username and password to use to log in as well. Once I have connected to the database, I can then, sorry, my brain just skipped a beat there. I can then start to form my query. So here's my query. Select first name, employee name from employees. That's the same query that I was running in PHP just a moment ago. The syntax is a little bit different. So I'm going to go ahead and execute it, grab the results set, iterate through the results set, and print out the first name column and the employee column. If there's an exception, I can't connect to the database for whatever reason, I've got some error handling down here to accommodate the various exceptions that might occur. And then I'm going to close the connection once I'm done. I'm going to close my database connection once I'm finished. So if I run this, it'll actually behave very similarly to the PHP example that we saw. and access the database that's on my computer. It's taking a little while because there's a lot of data to be fetched from the database. It's several thousand rows, I believe, but it did work. You can see all the data down here below. But again, this isn't quite as useful to me to just see a data dump like this. I'd like to be able to specify the data that I want to see from the database. So how can we parameterize this query? It's the same idea, but a little bit different. I'm going to ask the user to type in the first name and last name. And now if I look at the query in this particular example, you can see that I'm just using string concatenation here to tack on the first name and the last name. So if I run this particular example and type in good old Parto Bamford's name again, first name is Parto, last name is Bamford. You can see that it successfully fetched his record and printed out the data. I just use string concatenation to tack those values into the query that's being executed. So I wanted to show you this a couple different ways if you want to do this on a web application or on a desktop application, standalone application. Again, these are just two examples. If you do this in Python, if you do this in C#, if you do this in JavaScript, the process is going to be generally the same. Are there any questions about this before we talk about something a little bit different? So what I've described to you then is a little bit old school. It's actually, especially with object-oriented languages, there's a more modern way of thinking about databases and how to use them in your programs that I want to talk to you about and show you some examples of. Did the Java examples. There's this concept of object relational mapping. And the idea here is that I have objects, maybe they're Java objects, right? Java classes, Java objects. And I have values in my database, right? There's stuff in my database. And what I really want to do is map the two. I want to map the database rows to Java objects, and also vice versa. I want to map Java objects to database rows. But basically what I'm asking for is the computer to do the work for me to create objects out of the data that's in my database, and also take an object and put it into the database. There's a lot of work to do that, and I can do it manually. I can go through all of the fields, right? Form an insertion statement that maps the fields of my object to the columns of my table. I can do all that myself if I want to, but there are ORM libraries that will do this for us, and it minimizes the amount of SQL that's necessary to execute, to put data into and fetch data from your database. So I want to show you an example of what this looks like in code. Again, using Java. I have a Java example. Here is a class that represents cheese. It's a cheese class. We've all written cheese classes before, right? This is a cheese class. And up top, I see the fields. Cheese has an ID field. It has a name. It has a description. It has a category. Quick, how many categories of cheese can you name? Oh, too slow. There's hard cheeses. There's soft cheeses, creamy cheeses. Anyway, these are all the fields that are contained within the cheese class. And what I would like to have is a table in my database, or maybe even multiple tables, that has a ID. It's a cheese table that has an ID column, and it has a name column, and it has a description column. And I want to be able to give the database a cheese object in Java and say, put this in that table, and not have to worry about how to write the SQL query to make that happen, right? I don't want to have to worry about that. I just want to give it to the database and say, put it in the table. And I want to be able to do the opposite too. I want to be able to say, give me this cheese from the cheese table and turn it into a cheese object for me, right? Make a cheese object out of this row in the database and give it back to me so that I can do stuff with it. I want to be able to make that mapping back and forth. And so I'm using an ORM here. to do this for me. And the ORM, you can see, uses these things, these yellow lines that start with the add. Does anybody know what those are called? Beans. Beans. Not quite. They're often used with beans, but these themselves are not beans. They're annotations. Good. They're annotations. I'm using Java annotations. A Java annotation is not a functional line of code. You can think of it as a labeling exercise. I'm labeling different parts of my Java code. Or basically what you're doing is you're giving hints to the compiler. I want this piece of code to be used for this purpose. And the compiler will say, oh, okay, I know how to do that. And it'll hook the stuff up for you behind the scenes. And so what are these annotations telling us? I see the first one at the top here is an entity. This annotation is saying, I want to use this class to map to a table in my database. And this will quite literally look for a cheese table in the database. It's going to look for a table called cheese in the database. I'm basically telling it that I expect there to be an entity in my database called cheese. And then if I look at the annotations that appear above the field, right, we can kind of distinguish what these mean. This ID annotation indicates that this is what? It's the primary key. I'm marking this as the primary key. Generated value means what? Auto increment. Auto increment the primary key for me. And then here, right? The name cannot be null. Size has to be between 3 and 15. I'm applying constraints to this. We know how to do stuff like this in SQL. I've shown you how to do basically all this stuff writing SQL queries. But by using an ORM, it can do all of this for me on my behalf. It can do all of this for me on my behalf. It can even go so far as to create this table for me on my behalf in the database with the constraints that I have specified. So then, you know, I've got the different properties here, and then down here we see another interesting one: many to one. That sounds like what? A join, or what do we use to accomplish our joins? Rhymes with relationship. I don't know. Or it's a relationship. It's a many to one relationship, or a one to many relationship. This actually, we're indicating that this is the one side. One cheese can have many. No, one category can have many cheeses, I think is a better way of saying it, right? Yeah, this is the many side of the relationship. One category can have many cheeses. And so what is that telling you? That's telling you that there's another table in the database called category. And this will actually generate the appropriate foreign key relationship across the objects based on whatever category object is listed here. Because a category object is also going to have an ID. Also have a field marked as ID. So it's doing all of the wiring for us. It's wiring everything up for us and making the database for us based on the objects and how we've annotated these objects. So then if I want to put stuff into the database or fetch stuff out of the database, it becomes a lot simpler now. I go to, whoops, I looked at the wrong file. Let me pull up the correct file here. This is not the right file, sorry. I want to look at the controller. I'm not going to go through all of this code. I'm just going to do some highlights here, right? If I want to look cheese up, where is it? Whoops. I'm missing it. Hang on. Well, here's how I put cheese into the database. This line right here. Cheese DAO. DAO stands for Data Access Object. This is what bridges the gap between my objects in Java and the database. This is what's going to form the appropriate SQL to do the insertions or the retrievals based on what I'm trying to do. Cheese DAO.save, and then I pass it a cheese object. This is just an instance of the cheese class. I pass this to my data access object. It figures out what SQL statements are necessary to put that cheese object into the cheese table of my database and executes those statements for me on my behalf. And I can look things up as well. Let me find an example of that in the code. I'm sure there is one. Where is it? Well, here I see, Okay, well here's one. CheeseDAO.findAll is going to give me all of the cheeses, right? That's a select star from cheeses, right? That's a select star statement. But I can also find individual things, although I don't see an example here of finding an individual one. Oh, well, I see a category DAO. I can pass it an ID number. I can pass it a primary key and say, look this specific one up and give me that object back. So these ORMs, notice I have not shown you a single SQL query. I've not shown you any SQL whatsoever. I'm using the data access object and the annotations on my Java objects to have the system set up the mapping between my Java objects and the database. It's called an object relational mapping. Object relational mapping. These have become very popular in recent years, so especially with web programming, very, very, very popular. If you there are some downsides though, right? Can anybody think of why you might not want to use an ORM? What's a possible negative of using these? They seem pretty cool. They seem like they make your lives easier, right? What's a possible downside of this? Yeah.
So because there are many layers, it has the overhead.
So overhead's definitely a concern. How good is the SQL code that this thing, how good is the SQL code that's being produced by this thing, right? That's a question to definitely keep in mind. Is this writing good SQL queries? Is this going to be as good at writing SQL queries as a human? In some cases, the answer might be yes. In other cases, the answer might be no. Maybe it would not be as good as if a human writes it. But there's another deeper issue with using ORMs that people are starting to wrestle with, which is this allows me to use a database when I don't really have any idea how a database even works, right? I don't even need to know SQL to use this, which might seem like a plus. If you don't want to learn SQL or you don't know SQL, but you still want to use a database, that might seem like an advantage to you. But there's still enough going on here to where if you're not familiar with how a database works, if you're not familiar with how to write SQL queries, you can get yourself into some sticky situations that you're not going to be able to get out of. Or in other words, it's really leading to, in some cases, very inefficient databases, because these databases aren't necessarily designed properly. Like nobody's sitting down to design these databases. The databases are built based off of the Java objects. Is that the best way to design a database? You could argue that maybe it's okay, but I think you could argue that actually that's probably not the best way to design and implement a database. So one of the main arguments against object relational mappings these days is it allows people to be lazy and sloppy with their databases. So some people will avoid them entirely for that reason. Consider that if you do, right, what are you on the hook for? You're on the hook for managing your database connection, writing the appropriate database queries, right, and retrieving the data from the results and creating those objects yourself. That's what you're on the hook for. It's more work, but you also have more control over the situation. You can fine-tune your queries. You have a lot more control over what the structure of your database is going to be, and more control over the system as a whole. And you understand what's going on a lot better. Yeah?
We had a problem like this at work where there was a setting in our code we didn't know about, and every time we push the code up, it drops the database and rebuilds it.
Yeah.
So the inserts we had running in production got wiped.
Got wiped.
Oh,
yeah. For sure. I mean, that's sort of another major complaint of using ORMs is that it hides stuff from you. It hides stuff under the hood. This is running SQL queries. Whenever I run statements like this, it's running SQL queries. Can I see what those queries are? Yeah, but I got to go looking for them, right? I really have to dig to find out what they are. It's not out in the open. It's not transparent. It's not readily available to me. I have to go looking for it. ORMs hide stuff. And in an era when code transparency is becoming a big topic, that's seen as a negative, seen as a downside. So you sort of have to judge, right? The ease of use of an ORM is undeniable, I think. Very simple to use. Makes working with databases a lot easier, especially if you're not comfortable or confident with your SQL skills. But there's a price. There's a price that you're paying for that convenience. Are there any questions about that? So then, I would be very surprised. I would expect you all to run into ORMs at some point in your programming career. They're popular enough to where I think you're still going to see them on a regular basis, and they're not all going to look like this. This is a Java ORM. What is this one called? I want to say it's called like JData or something like that. I can't remember what the exact name of the ORM is, but there are many different object relational mappings out there, and they all operate a little bit differently. This isn't even the only one for Java. There are other ORMs for Java that don't work like this. They work a little bit differently. They're all kind of the same, but they all have their own little things that you need to learn how to use to get things done appropriately. All right. How many of you work with ORMs? I know you work with ORMs. How many else of you work with ORMs? A few people? Nice. Are you generally in favor of them or no? Thumbs up? You lazy. No, never mind. Never mind. I won't go there. I see a big thumbs up over there.
Well,
you just told me how it caused a big problem.
You don't have a service layer or a repository layer. And in the repo layer, you can create native queries all you want. Aren't going to get with a regular thing like that. You just get create, read, update, delete, basics, find.
Right.
Find all. But if you want some crazy join, you have to custom write that yourself.
Yeah.
Repo and then have to.
And I think that's a good point here. I think you actually made an excellent point. There are still ways that you can inject your own custom SQL into an ORM to do specific things. Actually, the way to do that, and I sort of glossed over it, is the data access object. This data access object is extremely bare bones, right? It doesn't really get any shorter than this, because it's doing your basic creation, deletion, update.
You use the add query or add native query underneath that and make your own.
You can add custom queries into this class, yes, to do your own SQL magic. Yes.
I was gonna say, I'm also big in favor of them because for most of the very big name ones, created by people who work in databases day in, day out, and dedicate hours and hours into this, weekly or daily.
Sure.
And probably will do a better job writing the underlying queries than I could spend by hand.
That's true. So I think that's a fair argument in terms of what kinds of queries are being generated. But the issue still remains, like, is the database that's designed, is it a good design? Because that's still in the programmer's hands, right? It used to be that database design was only something that experts can do. But now that ORMs are popular, it's something that any programmer can do. Any programmer can design a database just by defining objects and specifying templates, which is kind of a scary thought, because does the average Java programmer know how to design a database effectively? Maybe. I kind of suspect the answer is not really, right? So it could lead to code that is functional, but perhaps it's not the most efficient that it could be, or a little bit of a sloppy design, perhaps. But there are obvious advantages. I actually am a fan of ORMs myself. I don't want you to walk out of this room thinking, oh, Professor Shook hates ORMs. No, that's actually not true. I like ORMs as well. I would also give them maybe like a 3/4 thumbs up, right? Like mostly up, but I do see some disadvantages of them as well. Cool. Any other questions and or ORM horror stories? Those are fun too. No? All right. We can chat about those after class. We don't need to talk about them now, I guess. Let me get back to my slides here. That's what I wanted to look for. All right, cool. Yes. All right, cool. Yeah. All right. Now we're going to have some fun. So for the next little bit of time, you all are going to become hackers for the rest of today. We're going to talk about SQL injection. If you're building a front end, a SQL front end, you have to be aware of this very important fact. We're accepting input from our users. What if the input isn't what we expect it to be? So if I ask you for a username and a password, I expect you to type in your username and a password, maybe literally the word password. No, don't do that. Pick a better password. But for some people, yeah, that's what they're going to type in. I don't expect you to type in code, usually, right? How many text boxes have you seen on websites that actually expect you to type in code? There are websites specifically designed for that sort of thing, but your average website, your Facebooks, your Reddits, your other things aren't expecting you to type code into those boxes. And so this is not a new concept. but people have figured out that if I do type code into the text box, I can get some information that maybe I shouldn't have access to otherwise. This is called SQL injection. And actually, we're going to talk about SQL injection because this is a database class, but the problem is actually more widespread than just SQL injection. I can inject any kind of code into a text box. So if I know that your website is using JavaScript on the back end, I can try to inject JavaScript code and mess with your JavaScript. I can try to inject Python code to mess with your Python. Those are all things that are possible, right? In this class, we're interested in databases. So we're going to focus on SQL injection, which is probably one of the oldest and most well-known forms of code injection. I'm sure most, if not all of you, have seen the famous XKCD comic about SQL injection, where the mom is talking to the school administrators about why she named her child Little Bobby Drop Table, because it corrupted their entire database. So let's talk about SQL injection, how it works. If the input isn't what we expect, specifically if the input is a SQL, some SQL code, right? Here is what the query looks like. Here's what the query might look like that's being run to look up a username and password, right? If my name is Jake, it's not. But if it was, and my password was Jake's password, it's not. But if it was, I might substitute those into the query, right? Select everything from users where the username is Jake and the password is Jake's password. And if it finds this user and this password, then it's going to say, all right, that's a success. I found the user. You can log in now, right? You can log in. This exists. I found a row with this information. It exists. Well, what if I just tack a little bit of extra on here? Password equals Jake's password, or X is equal to X. Well, this is always true, right? So now, if the password doesn't equal Jake's password, that doesn't matter anymore because this is going to be true. It's going to find a row from the database, right? And it's going to say, oh, okay, cool. I found a row from the database. You exist as a user. You can now log in. I have now tricked the database into allowing me to log in, allowing me to log into the database. It gets worse. It does not get any better. I can do things like inject, HTTP requests into a website. So this example down here at the bottom of the screen, translate is a function that we haven't talked about before, but basically the translate function allows you to do string substitution, basically, right? String substitution. So what I'm doing with this SQL query down below is using string substitution to substitute in a website, probably a website that I control, that I know of, that might contain malicious code that I want to run, right? Or whatever I want. So that when this is executed on the server, if I inject this into a website, it's executed on the server, it will access this website, grab whatever malicious code I have at that website, move it onto the server, and now I have access to your server, right? It's another way that SQL injection can be used to compromise the integrity of a server. So SQL injection can be used for all kinds of things. Database fingerprinting is this idea of just trying to figure out what the structure of the database is like. What tables exist? What columns exist? This is not particularly useful on its own, but it can be useful to perform more sophisticated attacks. Like if I find out that you've got a credit card number column in your database, well, hey, I just figured out what I'm going to try and explore a little bit more, right? That's where I'm going to go next. It can be used to do denial of service attacks. I can shut your website down by injecting code that's going to perform a lot of requests and keep my server too busy to take in, other people's requests. I can bypass authentication. I can trick your database into accepting my password, even if it's not the right password, using a similar trick to the one that we just looked at. Identifying what parameters are injectable. Maybe the password field is locked down pretty well, but maybe I can inject stuff into the username field and have better success, right? Maybe I can get in that way. Executing remote commands is actually what we just saw on the previous page here, right? To access a different website that might contain some malicious code to do something that shouldn't be done on a server. Performing privilege escalation is maybe I'm just a regular user on the site. I can trick your database into thinking that I'm an administrator instead. And now I have access to all the administrator controls. I have the keys to the car at that point. I can do whatever I want. SQL injection can be used to do any of these things. We're going to take a look at, first we're going to take a look at how to protect against SQL injection, and then I'm going to give you a chance to actually do some SQL injection, do a little exercise. The classic way of protecting against SQL injection is to bind your parameters. We actually saw this. On the PHP side. We didn't really see this on the Java side, but here is a Java version of parameter binding. Notice again, I have the question marks in here as placeholders, right? I have the question marks in here as placeholders, and then I'm calling set string. You might be asking yourself, what's the difference between calling set string to substitute a value in here and just using string concatenation to put the value inside of that string? Does anybody know what the difference is between using set string here and the example that I had before, which just used string concatenation? What's the difference? What is set string doing for me that's protecting me? Set string is looking for things that might cause problems, things like punctuation that I wouldn't normally expect to see, parentheses, semicolons, right? Things like that. It might even be looking for specific keywords, right? Might be looking for from, or, and, right? Specific keywords that might be innocent, but perhaps aren't. And then what it's really doing to help protect me is it's escaping them. It's escaping them. And by escaping them, what do I mean? I mean that instead of treating this as a piece of code, it's basically wrapping it in a string and treating it as a string, not a piece of code. Does that make sense? Concatenation would stick the value directly in this slot, but we're basically wrapping an extra layer around our parameters in this case, basically forcing them to be interpreted specifically as strings, not as pieces of code as they get passed. You can think of it as wrapping single quotes around things or putting an escape character in front of it, slash in front of it to treat it as an escape character instead of an actual piece of code that's being executed on the server, right? That's what this method is doing for us that string concatenation will not do for us. We can also do input validation. So if I'm having a user type something into the box, just look at what they typed in. Did they type in SQL keywords? Well, maybe I should tell them not to do that, right? Reject it, toss it out. What are you doing here, right? You typed in some SQL stuff. Aha, I got you, right? Type in something else. That's one thing you can do. Function security is making sure that functions that can potentially be used for bad purposes, like this translate function, are very strictly locked down so that only privileged users can use those functions. Not just anybody can. And if you're interested in SQL security, right, there is a website, Bobby Tables, from the very famous XKCD. Here's the comic actually. First search if you type in Bobby Tables. Can I view the image, please? Yeah, all right, here's your son's school. We're having computer problems. Uh-oh, did he break something? Did you really name your son Robert Drop Table Students? Oh yes, little Bobby Tables. Oh no, we've lost this year's student records. I hope you're happy. And you've learned to clean your database, right? Oh, little Bobby Tables. This comic is a classic, so much so that now Bobby Tables is a very famous website that is a guide to preventing these kinds of attacks in any language. So pick the language that you're interested in working with, right? Oh, I'm connecting to a database using, is Python on? There it is, Python. Yep. Here's what you should do, or here's what you, right up here, it says don't do this, right? Don't use string concatenation, basically. Spoiler alert. Almost all of them are going to say don't use string concatenation. That's a bad way to do it. Instead, use parameters, right? Use a parameterized query. Submit things in that way. That's a common refrain. It's a common refrain, common way of handling things. For Java, I'm sure it says something similar to what we've seen. Oh, it depends on the driver. Yeah, it depends on what driver you're using. Interesting. Here's a parameterized query, right? With the question marks. Use set string, set int, whatever the case is. Right? Do not use string concatenation. That's a bad idea. Don't do that. That's a bad idea. So, are there any questions on that? Next thing I have is an exercise. Yeah, what's up?
This might be a little outside scope, but a lot of times APIs for hacking the database will have ways of amortizing fields or columns, but not something else like a table. So if we need that to be a dynamic query, like sometimes they need to like manually escape and filter instead. Is there anything else that needs to be done outside of like adding or replacing or escaping quotes to avoid injection?
Escaping quotes. I mean, quotes is one thing you should be looking for, but a lot of other things will be looking for things like periods, parentheses, semicolons, right? Things that we typically expect to see in coding constructs, but are unusual to see. I mean, periods aren't terribly unusual to see in usernames. Parentheses are pretty weird to see in usernames, right? Periods are, I think, maybe a little unusual to see in passwords. Parentheses are probably unusual to see in passwords. In fact, a lot of times when you see those crazy password restrictions, sometimes those will be chosen in such a way as to prevent people from using parentheses, semicolons to inject code into the password field, as one example. So in general, to go to your table example, most libraries these days, most common languages have a library that can do escaping for you. And it's just a general purpose escaping function. So anything that you're worried about, any user input that you're worried about, just run it through the escaping function. It'll go through, look for any weird characters, wrap it up, make sure that it's safe. Yeah, it's a good general rule. This used to be a much bigger problem, you know, back in the earlier days of the internet, the 90s and early 2000s. This used to be a much bigger problem. We had a lot more people who didn't know what they were doing online, right? And other people who knew enough to mess with those people and break their stuff. And so to give you guys a little bit of taste of what SQL injection is like, we're going to do a little bit of an exercise here. There's a website specifically set up with some SQL injection exercises on it. It's called sqlzoo.net/hack. If you have your laptop, pull it on out and pull it up. If you don't have a laptop, find a neighbor, hang out with them for the next little bit, because I'm going to turn you loose on a SQL injection exercise today. I'm going to go ahead and open this up in my browser if I can. sqlzoo.net/hack. Oops. Okay. So up here they've got a very simple username and password box, right? Very simple. Type in your username, type in your password. It doesn't go anywhere. This is just for example purposes. It's not a real website, right? But the idea here is that we can try some simple SQL constructs to see if we can find some information out about this website and the users who use it. So let's say, for example, that we know there's a user whose name is Jake. How do you figure that out? You could actually use SQL to figure that out if you wanted to. We're going to start with that piece of information. I know there's a user. I know his name is Jake, right? The user's name is Jake. What if I wanted to figure out Jake's password? I want to know what Jake's password is. I can use a series of SQL statements to help me determine what his password is. So here's some simple examples. First one, find out if Jake's password includes the letter W. So we're going to enter Jake as the username, and we're going to enter this as the password. So what's happening here? I'm using an OR statement. Exists. Select everything from the users table where the name is equal to Jake, and the password is like. So this like keyword is definitely something that we have not seen before. Does anybody know what that is in SQL? Like? Does anybody know what that's used for? Regular expressions. Oh, yeah, everybody's favorite. Everybody's favorite. Regular expressions. Now, The bad news about SQL regular expressions is that they don't look like any regular expressions that you've ever seen in your life. I promise you they don't. The percent sign here is a wildcard. That's what would normally be a star in most regular expressions. I don't know why they don't just use the typical regular expression syntax, but they don't. So this is saying star W star. Look and see if there's a W anywhere in that string, right? Any letters can come before it, any letters can come after it. I just want to know if there's a W in there, right? And so then if we paste this in, to the password box and hit submit, it says, welcome, Jake, you are now logged in. And because it successfully logged us in, we now know there is a W in that password somewhere. There is a W in that password somewhere, right? So then we can do additional queries to try and find some other information. This is asking if password is the third letter. So another regular expression, this time you see underscores. Underscore is basically, this can be one character. I don't care what that character is, right? So any character, W, and then anything can come after that. Is W the third character in the password? You can put that into the password field and see if that's what the third letter of his password is. If that's where the W falls in the password. So what I want you to do, I'm going to turn you loose, right? You know this guy Jake exists. You know that he's got a W in his password. See if you can figure out what his entire password is. Not just what letters are in it, but what his actual password is. See if you can figure that out. There is a little bit of a trick in there that you'll have to pay attention to. I'm going to give you, 10, 15 minutes to work on this, and then we'll talk about this. We'll go through the solution in just a little bit. I'll be around if you have any questions, okay? His password is not password. I'll give you that.
Exists. Then you see, so we don't think they have all the letters in the text, and then we just sort of cumulatively built up. So it's like, oh, well, this failed, succeeded, okay. Password like underscore. Yeah, okay, underscore. And then kept trying L, underscore. It was kind of cumulatively built up. Queries. You check the correlations between values. You can apply it. These are the starts of so Robert Ron Dan.
Did you get it? Nice. Do a few more. Give people a few more minutes.
Yeah. Yes,
Or unit house.
Right. So we have one wireless house, right?
Is there one single? No, I think it's probably generally a multi-step process. I guess theoretically there might be a way to just recognize that. That's true. That's one thing that's been developed to prevent this. Views don't necessarily prevent people from setting those up because you can't get in through a view. Yeah, depending on what kind of view you set. Views can be locked down, just like cables. So, yeah. Does. I want to talk to you about that, yeah. A little bit later on. Talk about this exercise. How many people think they got it? Or know they got it? A few? Alright, couple more minutes. I have put some additional queries up on the screen that may help you if you are currently stuck looking for ideas. Take yourself off of here.
That's what I was trying to
On the your whole partner can use your want to take a presentation and still yourself.
Yeah, I think whatever you want. It's like
You move yourself. Oh. Okay. All right, we're running out of time, so I understand that you may not have completely gotten it. I know some of you have gotten it. Let's have a little chat. See how well you did. I need some chalk. All right. So I imagine the first thing that a lot of you did was probably just try to figure out what letters are in the password, right? You might have brute forced it and just said A and then B and then C. Does that sound like what a lot of you did, right? Maybe a little tedious perhaps, but it would get the job done. So what letters did you discover were in this password? We know W was in there, right? Because I spotted you at W. What other letters did you find? E? D. There's a D. All right. So these are the letters that are in the password. What did you try to do next? I'm interested to see what your next step was. Yeah, go ahead.
We execute queries for an existing select star functions where maybe the big password and we just tried each letter, and then once we got the first letter, which is W, said underscore at the end of W.
You got the first letter was W?
Or sorry, E.
Yeah, I was gonna say.
Yeah, no.
So you figure out that the first letter was an E, right?
Yeah, then an underscore, found that as an L.
And then you did another underscore, right, for the second one. So
Yeah.
you're using kind of like this bottom query, right? And just
Right,
putting in different letters,
yeah.
different numbers of underscores, and then different letters, and to figure out.
So first E underscore, then EL underscore again.
Yeah. Any different approaches that worked out, or did most people do it that way? Any other approaches? Yeah. The size. Okay. Did it work? Did you find the length?
Yeah.
Yeah, and the length is 6. So that actually tells you some information, right? There's only 5 letters here. We found that the length was 6, so that means one of these is showing up more than once, right? There's a dupe, which is not surprising. It's not unusual necessarily, right? And so then, I mean, your method would certainly work to find the letters in order. Anybody else try a different method? Yeah. Oh, interesting. So maybe kind of like a dictionary sort of deal, right? Assuming that the password would be a plain English word, which it's kind of is, right? Interesting. May not always be successful going that route, but actually I think you'd probably be more successful than not in a lot of cases. People are still not great at picking good passwords for themselves. Yeah. And so then the actual answer, do you not want me to spoil it for those of you who haven't figured it out? I don't know. You guys get mad at me? Too bad. It's Elwood. Right? Elwood? There's 2 O's in there, so that's the duplicate letter. Elwood, I think it's probably a Blues Brothers reference. I don't know. That's before my time even. Definitely before probably you guys' time, Blues Brothers. But I think what's interesting is that so this website also provides other little exercises that you can do to find out what users exist. So if you are looking for a fun way to spend your Wednesday night, you can continue to hack this database. There are other users that exist with other passwords. So you can go and find other users. You can go and find other tables, right? This kind of SQL injection is not going to be very effective in most cases. There's a very easy way to avoid this kind of SQL injection. What is that? Somebody asked me about it actually. Common technique that we do these days with the passwords, we're not going to store the passwords in the database. We decided a long time ago that that's a very dumb thing to do, right? So now we hash them. We hash the passwords. You type in your password, we hash what you typed in, we compare that against the hash that's stored in the database, and if those match, then you typed in the same thing. That will foil this plan, right? Because now it's not going to know if W is the fourth character or not. It's hashing whatever you type into that box. It's going to get turned into gibberish, and the comparison is going to fail every time, right? Every single time. So hashing foils this. However, SQL injection is still a viable method of attack. It's just a little bit more sophisticated now. It's a little bit more complicated than guessing letters in a password. So this technique still is used, still is dangerous, still is something that programmers need to be aware of. Is not as dangerous as this website makes it out to be. Is also very much illegal and will get you in big trouble. So if you get caught doing this, don't mention my name. I had nothing to do with it. You're on your own. I hope you have a good lawyer. Are there any questions? Yeah, in the back.
How can you track the SQL injections? How do they find people to prosecute?
How do they find people to prosecute? So anytime I log on to any kind of a server, I'm leaving a trail. A good server is going to log every single action that takes place. So even if I log in as someone else, right, it might log the IP that I logged on from, which is going to give me clues. And there are ways to obfuscate those things as well, right? But if I do it enough times, they'll be able to use the information to find me somehow or another. And also, too, it's like, who are you going up against? You're going up against law enforcement, maybe even the CIA if you're doing some real crazy stuff. I'm sure their resources are vastly superior to any resources that I have or you have, right? They got stuff that I can't even dream of to come track you down. I don't even want to think about it. So on that note, stay out of trouble, everybody. And if the CIA is watching this video, I have never done this before outside of class. We're all good. Have a good weekend, everybody. Have a good fall break. I'll see you in a week.